Hey guys, it's Mr. Gron coming to you from my bedroom today. Don't believe me? There's my bed, chair, closet, all that stuff. Kind of bare in here. No taxidermy like in the garage. But I thought I'd make a video tonight to go over some basics with Soh-Cah-Toa and just to throw it on the website if anybody needs a little extra help. So when we're talking Soh-Cah-Toa, we're talking right triangle trigonometry, right? So here's our right triangle. There's a right angle. We've got a little theta right there. That's basically just like x, but a special x for trigonometry, for angles. Alright, so the OH and the A, that refers to the opposite, adjacent, and hypotenuse of our right triangle. So the first thing that you always want to do with these is identify on the opposite side of the triangle from the area is the opposite side. The right angle points at the hypotenuse, which is also the longest side. And then the remaining side is the adjacent side. Now adjacent means next to, so this side is next to the angle but not the hypotenuse. Alright, so then our ratios are sine of theta is our opposite over the hypotenuse. Cosine of the angle theta is adjacent over hypotenuse. And tangent of theta is Soh-Cah-Toa, opposite over adjacent. Okay? Now, in 10th grade and in geometry you learn about these three. There's actually three more reciprocal ratios, which are these. Cosecant, which goes with sine. It's the reciprocal, so all we do is take the opposite over hypotenuse and flip it. And it's hypotenuse over opposite. Cosine, the reciprocal is secant, which would then be the hypotenuse over adjacent. And then tangent is cotangent, which then becomes adjacent over opposite. Okay, so those are our basic ratios. Now, an example of where we would use this. Let's say I've got right triangle here, and my side lengths are 3, 4, and 5. My opposite side is 3, my hypotenuse is 5, and then 4 is my adjacent side. I'll try to get my shadow out of the way so you can kind of see that a little bit better. Let's maybe try to make this a little more of a right triangle. Make our triangle a little more right. There we go. Something like that. That looks a little bit nicer. Alright, what are my 6 trig ratios here? Well, sine is opposite over hypotenuse, so 3 over 5. Cosine is adjacent over hypotenuse, so 4 over 5. Tangent is opposite over adjacent, which is 3 over 4. Then our reciprocal ratios, cosecant, I just flip the fraction 5 over 3, and I'm going to leave it just like that. I'm not going to change it to like 1 2/3. Secant goes with cosine, and that instead of 4 over 5 will be 5 over 4. Tangent is going to go with cotangent instead of 3 over 4. It is 4 over 3. Okay, so pretty basic example there. Now a couple of details with this. Let's say that I've got a triangle like this. We'll leave, I guess I could have left those, but let's say my triangle has a side of, I don't know, 12, 16, and 20, and I want sine of theta, which is going to equal opposite over hypotenuse, so 12 over 20. We're in high school. I would expect that we can reduce this fraction. 12 over 20, those are both divisible by 4, that would reduce to 3 over 5. Okay. Another one that we might see would maybe be something like this. Now I'm just literally making this up off the top of my head, but Let's say that the opposite is, we'll say the opposite is 5. We'll say this is 7. So then the hypotenuse ends up being the square root of 25 plus 49 is 74. Something weird like that. Okay? Totally possible that you could get something like this. 5, 7 square root of 74. There's my opposite, there's my adjacent, and here's my hypotenuse. And let's say I want to find cosine of this one now. So I do cosine theta, and that equals adjacent over hypotenuse 7 over the square root of 74. Something kind of weird, right? I need to rationalize this denominator still, just like we did last unit. And so I'm going to do that by multiplying the top and bottom by the square root of 74. That's going to cancel out the numerator, or the radical symbol. And then on top, it'll be 7 square roots of 74. That would be like the full credit answer for something like that on the test.